What's up, wrestling fans? Miss Sorensen here with adding vectors in physics. Well, we've already talked about adding vectors, but we're now going to talk about it in terms of physics. And physics usually talks about force. And the unit that we're going to talk about here is newtons. So whenever you see an N, just think about that as being a force. Someone's pulling, say, a rope with 100 newtons. You can think about, if you want, Miss Sorensen right here walking Jasper, and Jasper's on the end here and really pulling hard with 100 newtons. Versus, say, Allie comes over to cat sit and she's got Percy, and Percy's a small kitty, very skinny, only eats dry food, and Percy pulls with a lot less force, let's say 50 newtons. So we can go ahead and we can add these vectors, and there's only one reason why we can add these top two vectors, and why do you think that is? It's because they're going in the same direction. So all we have to do here is say, okay, 100 newtons plus 50 newtons means that if both these cats are pulling in that direction, there's going to be a total force of 150 newtons. And I want you to think about if Allie had both cats in her hand, right? If Jasper was pulling 100 newtons in the east direction and Percy was pulling 50 newtons and she had both cats on a leash in her hand, she would have an overall force or pull going in the easterly direction of 150 newtons. So now let's say Jasper kind of slows up a little bit. Allie's still holding this here, and Jasper's pulling with 60 newtons to the east, and Percy decides to turn around and head in the opposite direction, in the westerly direction. And again, Allie is holding 2, so really it looks like, here's Allie, she's got one string here, and then she's got another string kind of going in that direction. So she's got a cat here, and then a cat here, and they're both pulling in opposite directions. So what would be the overall force that Allie's experiencing here? Well, this one's going east, this one here is going east, and this one's going west. And which one's bigger? Well, clearly this one's bigger, so there's going to be more force going in the westerly direction or left. And if you think if 60 is going here and there's 90 going here, it's going to end up being 30 in this directions. My arrow is not super flat, is it? Does that make sense? If you really want to, you can think of this as 60 newtons minus 90 newtons, and that would be negative 30 newtons. And since it's kind of negative, it's going to end up being in the other direction than where we started with this situation. All right. Okay, now how about one where we are pulling 80 newtons north and then 120 newtons south? Well, I would say, hey, this is going to win out, so our ending force is going to be down, but since there's 80 newtons pulling it up, we're going to be left with 40 newtons, and that's going to be south. And you don't have to write south if you don't want to. The arrow is already telling you it's south, but don't get confused with that N. It's not north, it's newtons. All right, let's go on to something a little bit more challenging. It's getting harder, so this is kind of our intermediate step here. Here's some notation I want you to be aware of. If I have F sub r, I might just call it FR at some point, no big deal. That's the resulting force vector, and that's going to be this vector right here. But if, Allie was holding something where my cats were flying up and over a tree, there would still be an X force, a horizontal component to that force, and there'd also be a Y component, just like the vectors that we were talking about. So we can always break down a force vector, the resulting force vector, which is a diagonal, into its X and Y components, and we'll call that F sub X and F sub Y, although sometimes I'll just call it Fx and Fy. Just note that this is the force in the horizontal direction, and F sub Y is the force in the vertical direction. All right, what do we got here? Well, we've got a 30 newtons being pulled to the right or going east and 40 newtons going north. And if you can think about this, right, if you had a cat running in this direction and then you were also holding a bird onto a leash and it was flying up, in general, the general force is going to be going like that. That would be the overall. So I kind of know that the overall force is going to look like this because some is pulling this and some is pulling that. So it kind of gets averaged out based off of the amount of newtons or force that there is. But the best way to think about this is with this picture right here. Remember, we have a horizontal force, in this case, which is 30 newtons. And we also have a northerly force, which is 40 newtons. And we're going to do Pythagorean theorem to get our resulting force, or F sub r. So that's going to be 30 squared plus 40 squared equals F sub r squared. This becomes 30 squared plus 40 squared. I'm just going to go ahead and do a shortcut here, and I hope you see what this is going to be already. What is it going to be? It's going to be 50, right? Because it's a 3, 4, 5 triangle. So it's interesting, we've got a 30 newtons and a 40 newtons, and we are actually going to end up with a 50 newton pull, which makes sense. We're adding a little bit of force because they're combining them. But what's the direction? This is something that we've not had to do yet. In the last one, we actually gave a direction and a magnitude, right? This is the direction south, right here. We're going south. That's our direction. And this is our magnitude, 40 newtons. You can think of that as the length, or you could think of it as the amount of force, if you will. And same thing for the previous ones, right? I gave direction in this one, which was right or east, and then I gave magnitude or length. So right now we have an incomplete problem where I've given the length or the magnitude, the same thing. I've given the magnitude, but what have I not given? I've not given direction. And I've already mentioned this, but to do direction, you can give either a direction like north, east, south, or west, or you can give degrees. And that's what we're going to do here. We're going to find this angle. And to do that, all we have to do is use inverse trigonometry. We've got opposite and adjacent. So we're going to do that our theta, our angle, is tan inverse of opposite over adjacent, which is 40 over 50, which is going to be equal to 53.1 degrees. So we're going to have 50 newtons, and you don't have to draw that picture anymore. We can now say it's just going to be 50 newtons at 53.1 degrees. But if you think about that picture, it actually makes sense, right? What's 53.1 degrees? It'd be something like that. So if you wanted to draw a final answer like this, you can, but I feel like this is totally sufficient. All right, let's try another one. And it's going to get harder, even harder. We have to derive some formulas here that's going to help us out. So the first thing we're going to derive is f sub x. Well, to do that, I'm going to circle this, and I know that I'm going to have, oopsie, my f sub x is going to be my adjacent, and this is going to be my hypotenuse. So if I want to solve for f sub x, I'm going to use adjacent hypotenuse is going to be cosine. So I'm going to have cosine of theta equals f sub x over f sub r. I want to multiply by f sub r. What happens on the right? We've got to cancel. So we're left with s sub x equals f sub r, or the resulting force, times cosine theta. So that's this right here. Do you have to derive that? Nope. Will I give that to you on the test? Yes. I just want to show you where that came from. Next one here on this list here that I want to derive is this one. Well, that would mean that I've got an opposite here. So I've got sine of theta equals opposite over hypotenuse, which is f sub y over f sub r. Multiply by f sub r, or fr. Cancels out. I'm left with my y force. F sub y is equal to fr sine theta. So here that is right here, f sub r sine theta. All right, what are the other things that I've derived? Well, this one right here just comes from the Pythagorean theorem. It's basically saying in order to find the hypotenuse, you would just do the square root of x squared plus y squared, or the forces on the x and the y. That's Pythagorean theorem. And then tan inverse, this one comes from the fact that theta equals tan inverse would be opposite over adjacent So we could find that angle by doing f sub y over f sub x. This might feel really uncomfortable to you right now because we haven't used these formulas, but as of right now, all you need to know is that these formulas exist to help us, and you need to get them down, and they will be given to you on your test. All right, example 5. We are going to add 100 newtons plus 150 newtons, and notice that it is going 30 degrees. I could put a little degree symbol there. And so, you know, I would kind of guess, what do you think the answer is going to be? Well, since we've got a force pulling us directly east or directly to the right, and the other force is pulling us maybe slightly up, my guess is that our resulting vector is going to be like maybe little bit less than 30 degrees because you've got some force pulling you horizontally. That's my guess. But let's go ahead and to do these problems, we basically have to find what f sub x is and f sub y is. And it's a lot easier than you think. What I want you to do is split this problem down the middle. And I'm going to call this force 1. So this is force 1, which is equal to 100 newtons. And the theta is going to be equal to, well, what's this degree right here if you are graphing it on a coordinate grid? Yeah, it's 0 degrees. You could certainly say 360, but you're going to get the same answer either way. And this is going to be force 2, where my force 2 is going to be 150 newtons at theta equals 30 degrees. All right, so now I need to find my f1 sub x. So that means I'm finding this x component for my first force, and I'm going to use this formula right here. So that's going to be my force, which is going to be the 100 newtons. Okay, so that's going to be 100, and then it's going to be times cosine of 0, which is equal to 100 newtons. Then to find my f sub y, I'm going to use this formula. So again, we're doing the first force, but now we're going to do the y force. That's going to be 100 times cosine, oops, just kidding. What does this say here? It says sine. So this time I have to use sine of 0. Well, that actually gives us 0 newtons. Let's talk a little bit about what that means in a second, but for now, let's move on to the next one. So f sub 2x is going to be 150 times cosine 30 degrees. And make sure you've got your calculator in degrees, obviously. This one's going to be 150 sine 30. This one here gives me 129.9 newtons, and this one here gives me 75 newtons. So let's just break down what this actually means. For this right one, I think it makes more sense to start with this right one. Remember, we've got this kind of triangle-looking thing. If you want to put an arrow here, you can. But we're basically saying if I have 150 newtons and I've got 30 degrees right here, then my horizontal component is 129.9. That's, remember, my x. And then my y component is 75 newtons. Over here, however, we're only going completely to the right. So we actually only have 100 newtons in the horizontal. We have actually no y component to this. So what we really care about now is getting a sum. This is the symbol for sum. Don't freak out. That just means I'm adding everything up. I'm now going to add up my f sub x, meaning I'm going to take my x force from my first force and then my x force from my second force. I'm going to add those up. And that's going to give me 100 plus 129.9 is 229.9 newtons. And we can just now call this f sub x. We're going to do the same thing for y, f sub y. I'm going to add 0 newtons to 75 newtons. So 0 plus 75 is obviously 75 newtons, which is going to equal our f sub y. So basically what we've done is we've taken these two vectors, we've calculated what their horizontal and vertical components are, And then here we added the horizontal components of force 1 and force 2, and then here we added the vertical components of force 1 and force 2. Well, now that's going to help us out because we know that we can find what F sub r is by doing the Pythagorean theorem, because we basically have that this here is 229.9 and that this is 75 newtons. And so if we do Pythagorean theorem, which is this formula right here, we get what our resulting force is. So let's actually do that. That's going to give us 2, in parentheses please, and you can just, I would like to do the thing under parentheses first, or under the square root first, and then square root that number. But you should check that you get the same thing as me. I get 241.82 newtons. All right, well, that kind of makes sense, right? Because we've got 150 newtons and 100 newtons, and you can't just add them together because they're going in different directions. Speaking of direction, do we have direction yet? Do we have a degree, an angle? And the answer is no. We have to do this formula. So theta is going to be equal to tan inverse, and we're going to use F sub y and F sub x, which is located right here and right here. So this is going to be 229.9 all over 75, and that's going to give me 18.07 degrees. Now, on my part 2 of this video, which you need to watch part 2, I'm going to talk about how we can figure out what this degree is when we know we're not going to be in the first quadrant. Here, this is clearly a first quadrant problem. We're clearly going to end up in the first quadrant. And we can also know that because if we were to graph the coordinate 229.9 comma 75, we'd be in the first quadrant. So here we don't have to worry too much about it. But we will cover that in the next video, which is in the same assignment. So make sure you watch that. So our final answer here is 241.82 newtons at 18.07 degrees. And we really should check that the reasonable of this. So that would be, if you kind of think about your coordinate grid, and we don't need to do all 4, let's just do the first quadrant. You basically have 18 degrees, and it's going to be pulled 241.8 newtons. And that makes sense, right? Because you've got some horizontal force and some slightly up force. All right, please make sure you watch the next video in the same assignment, or else you're going to miss quite a bit.